Hello friends, in today's question, two rectangle box having identical dimensions can be arranged either in configuration 1 or in configuration 2 as shown in the figure. One of the block has a thermal conductivity K and other has 2K. The temperature difference between the ends along x-axis is same in both configurations. It takes 9 seconds to transport a certain amount of heat from the hot end of the to the cold end in the configuration 1. The time to transport the same amount of heat in the configuration 2 is. So we have two configurations. In configuration 1, they are connected one after another, and in configuration 2 they are connected on the top of each other. And it is said that the temperature difference between the ends along x-axis is same. It means temperature difference between this and this as well as these two will be same along the x-axis. And it takes 9 seconds to transport certain amount of heat from hot end to the cold end in the configuration 1. So total time taken to transport the heat from one end, let us suppose this is hot and this is cold, it takes 9 seconds. Okay, and it is said that how much time it is going to take to transport the same amount of heat. So if the heat transportation in configuration, let us suppose is H1, and in the second case it is, let's suppose, H2, then this H1 will be equal to H2, and we have to find out how much time it takes to transport the heat, same heat, the configuration 2. So let us start from this given information that heat transportation is same for configuration 1 and configuration 2. So we say heat transportation in configuration 1 is equal to heat transportation in configuration 2, or we can write that our H configuration 1 will be equal to H configuration 2, and this is, we can say, a standard formula, and with respect to, we can write it as K1 multiplied by area multiplied by delta T divided by total length, that is L plus L, and let us suppose the time taken is T1, and that will be equal to K2 A plus A, the temperature is same, delta T, and the length is L, in this case multiplied by T2, and the K1 and the K2 here are the, so we can say A are the area of, because the size and everything is same, so we can say area of the configuration 1 and configuration 2, area of configuration 1 and 2, and our L length, let's have a length of configuration 1 and 2, and T1 is the time taken for the transfer of heat in configuration 1. T1 is time taken in configuration 1, and that is given to us, this is over 9 seconds, and T2 is the time taken in configuration 2, and this we are supposed to find out. and we are supposed to find out in configuration 2. This we are supposed to find out. One second, please. Yeah. And K1 and K2 K1 and K2 K1 and K2 are the equivalent conductivities of configuration 1 and configuration 2 are equivalent conductivities are equivalent conductivities for configuration 1 and 2 respectively. So we can just manipulate, let us call this equation number 1, and we can say equation 1, we can write it as T2 will be equal to, because these parameters, let me solve it here only. So we can write this as K1, and we have area A, and this is delta T divided by 2L. This becomes K2, and this will be now 2A divided by L multiplied by delta T, this being multiplied by T1 and this being multiplied by T2. Length, area, temperature, these terms cancels out. So we get this as T2 will be equal to K1 upon K2 multiplied by T1 divided by 4. And let's find out what will be the relation between the conductivities which are given to us. So next is relationship between their equivalent conductivities. Relation between the given equivalent conductivities the equivalent conductivities are given as K and 2K, but the arrangement is different. You can see from the figure also the values are same, but the arrangement is different. The first they are one after another, and the configuration 2 they are one above the other. So for configuration 1 we can write for configuration 1 we can write that our equivalent conductivities L plus L divided by K1 will be equal to L upon K and L upon 2K, and from here we can say that 2 upon K1 will be equal to 3 by 2 upon K. So therefore we can write that our K1 will be equal to 4K by 3. This is for configuration 1. Similarly, we can write for configuration 2 also. For configuration 2, we can write that K2A plus A will be equal to Ka plus 2Ka. Now let me write it differently. This will be our 2K and multiply by A. So this gives us that our K2 will be equal to, this become 213, 3 by 2A. 3 2 by K, not A. So if we substitute this, let us call this an equation 2. So we can say from equation 2, we get our T2, which was our K1 by K2. We substitute value. K1 was our 4K by 3. This is our 2K by 3 multiplied by T1, which was 9 seconds. And now it's an easy calculation. We can say our T2 will be coming close to as 2 seconds. So if we check the options, that are option number A is the correct one. So we say option A is correct. So this completes the question. Thank you.